Welcome back. We are discussing about water quality parameters. In this video, we'll discuss about the bacteriological parameters. Here, bacteriological impurities, there are a number, different numbers are there, different types of organisms are there. And you can see viruses, they are nothing but infectious agents of both plant and animal cells, having a size of 10 to 500 millimicrons. And there are different types of bacteria, and some of them they can survive with respect to oxygen requirement. If they survive with oxygen, called aerobic bacteria. If they survive without the oxygen requirement or less amount of oxygen requirement, it is called anaerobic. And if they can survive with the presence of oxygen, without the presence of oxygen, it is called as a facultative bacteria. Some bacteria, they are temperature dependent. If they survive in the range of 10 to 20 centigrade, they are called as psychrophilic bacteria. In the range of 20 to 40 centigrade, they are called as mesophilic bacteria. 40 to 70 centigrade called a thermophilic bacteria. And if they can be present in soil or wastewater. And mainly we are interested with the coliform group of bacteria. They are present in sewage at a number 10 to the power of 11 to 10 to the power of 13 per person per liter of water. Presence of these bacteria in raw water indicates contamination of water. Now you can see in this picture how this bacteria is now entering coliform bacteria. It can come from stormwater runoff, maybe from houses, from septic tanks, and from manual waste and industries. All these things, they are now entering into surface water bodies. So the surface water is totally contaminated with this type of bacteria. Now we are having some different terminologies to understand. Total coliforms, fecal coliforms, and E. coli. Total coliforms means the bacteria that are found in the soil and in water. They have been influenced by the surface water and in human or animal waste. So it can present in soil or water where the inputs are coming from surface water, human or animal waste. So fecal coliforms, they are the group of the total coliforms that are considered to be present specifically in the gut, that is nothing but human discharges and feces of warm-blooded animals. Gut human or animal discharges. E. coli or Escherichia coli is a type of bacteria that normally lives in one's intestines. It is also found in the gut of some animals. So here, my only thing is E. coli is a indication that some unwanted things coming from animal sources is present in the water. That's why presence of E. coli indicates water contamination. Bacterial presence is mainly tested for its presence only. The indicative tests are performed. You see the representation here. Representation here you can see total coliforms and fecal coliforms is a part of that, and E. coli is a part of that. So if you are present testing for E. coli, then the remaining things can be easily understood. So all the tests are now for detecting the presence of E. coli bacteria in the water. So now you can see here, usually a membrane filter method is used for detecting the coliform group of bacteria. And some indications are also available here, guidelines. For total coliforms, a sample volume that gives 20 to 80 coliform colonies and the membrane filter should be used. For fecal coliform test, a sample volume that gives 20 to 60 fecal coliform colonies and the membrane filter should be used. If there are more than 200 colonies, dilute the sample and use the test procedure. So what you're having is you're having a membrane filter, has a fine porosity filter, which can retain bacteria. Now you see here, this is a filter where the number of bacterial colonies are present here. Total coliform can come from sources other than fecal matter. A positive total coliform sample should be considered an indication of pollution in water. So E. coli results should be considered indication of fecal pollution in water. So when you do the test, the presence of this type of numbers and gives indication that there is a contamination. What are the impacts here? Gastrointestinal illness such as diarrhea, nausea, and possibly jaundice, and some headaches or fatigue. Now, if you see the procedures, what I mentioned, in the total coliforms, you are going to use a membrane filtration. Passing water sample through a membrane filter and the bacterial loaded filter is grown on some specific agar, and then it is counted. Based on that, what is the total coliform count and fecal coliform count, they are identified. So now another thing is the MPN, most probable number, is another test which is used. They were having presumptive, confirmed, and completed tests are also used here. So we are mainly interested with the diseases caused by polluted water. So number of problems are there, as I mentioned: dysentery, cholera, fever, typhoid, vomiting, diarrhea, urinary tract infection, salmonellosis. So this is the waterborne diseases which are coming through bacterial contamination. If you look at the test here for E. coli, what we are saying is we take 10 ml sample, 1 ml sample, 0.5, 1 ml, 0.001, and 001. So that means 5 samples we are going to take, each are having 10 times dilution. And this sample is tested for bacterial presence as per the protocol. And number of these tested for bacterial presence. Now, which of these tested positive, which is negative, that you noted down. And the minimum volume of sample tested positive is taken. Reciprocal of this volume is considered as E. coli index. For example, up to 0.01, these 4 samples are tested positive and this is negative. The last value is 0.01. So a reciprocal of this is 1 by 0.01 is gives you 100 units of E. coli index per 1 ml. So if you are sometimes, instead of taking a random sample, you may take multiple samples. So say 30 tests are conducted each of the samples, and how many positive are taken noted down. In this case, 10 ml sample, 30 tests are conducted, 20 are positive, and the ratio we calculate 20 by 30, 0.667. Similarly, for other things also 10 by 30, 0.33, and so on and so forth. Now we'll take the difference here, successive values. These two values, 0.667 minus 0.333, are getting 0.334. Similarly, for others, we are going to calculate the difference. So now we take a product here. What is the product here? This 0.334 difference is coming between 1 and 10 ml. 1 and 10 ml. For this, between the values obtained for these values. So out of these two, which is highest here? 10 ml is highest. So this difference divided by the 10 is going to give you 0.0334. Similarly, if I take this 0.166, it is between 0.1 and 1 ml sample. Out of these, highest value is 1 ml. So divided by 1. Like this, we are taking here all the values obtained. You add up all these things. So the total summation is 7.2 here. So this is going to be the E. coli index of this particular samples. So if you are taking only one set of sample of 5 tests here, sometimes bias may be there. So in such a case, You go for multiple tests and then going to get a more unbiased value of the E. coli index. So another one, we are having the MPN, that is the most probable number. So in this, we are going to use same volumes, 10 ml, 1 ml, 0.1 ml, 0.01 ml, 0.001 ml samples. So any three successive volumes are considered. And here we are going to take multiple samples here of the same volume. A 10 ml, 5 numbers, 1 ml, 5 numbers, 0.1 ml, 5 numbers. Total how many? 15 samples. So here tests are conducted. The indicative tests are conducted. How many tests are conducted? There come out as a positive. How many are negative? That numbers we are noted down. For example, in this case, all 5 tubes are positive. Here, out of 5, 2 are positive, and here only 0. All are negative. So the score is 520 for a combination of 10, 1, 0.1. Like this, we have to note down. So here I am taking some value here. Uh, 10 ml 5 tubes 2 positive, 1 ml 5 tubes 0 positive, zero point 0.1 ml 5 tubes 1 positive. So my score is 201. In this particular case 520. So now we are having some statistical tables which are developed to calculate the MPN. And in this we have to enter into that particular column with these positive numbers 201. So MPN is equal to 7 per 100 ml. 7 per 100 ml. Because we started with the first three values 10, 1.1. Suppose we did not start with 10, 1.1 ml, but instead we started with 1 ml. That means the sample is actually diluted with 10 times. Instead of 10, you are taking 1. So whatever the value obtained here, you have to multiply with the dilution factor. If I'm going to the same 1 ml, 0.1 ml, 0.01 ml, and if I got the same score of 201, and the index is 7 here, statistical value, I have to multiply that with 10 times the dilution factor. I'm going to get 70 per 100 ml. This is how we validate the results. This. So now you see here, this is the extract of the water quality limits, and higher the heavy metals also, some of them are indicated here: arsenic, mercury, lead, cyanide, cadmium, boron, nickel. And bacteriological characteristics, you see E. coli index, total coliform bacteria, they are given here. And all waters intended for drinking, and for treated water intended for drinking. That means this is not treated, this is treated. And what you see in this particular thing is these should not be detected. These indexes should not be detected. Bacterial presence should not be detected here as per IS 10500 2012. The treatment, whatever we are going to give, it should be efficient in such a manner the bacterial count should be 0 in terms of these type of bacteria. So this is about the bacteriological parameters.